4 billion miles from the Sun, a world exists that most of us will never see with our own eyes, yet it has been watching the rest of the solar system since long before humanity learned to look upward. Neptune. A planet so distant, so deeply blue, that even light takes more than 4 hours to travel from the Sun to its surface. And here is something that might surprise you. Despite being one of the most violent and turbulent places in our entire solar system, Neptune is also one of the most tranquil to contemplate. It is a world of paradox, where the fiercest winds in the solar system rake across a surface so serene in appearance that it seems almost to emanate a kind of cosmic calm. Imagine, if you will, drifting outward through the darkness. You leave behind the familiar orbits of Earth and Mars. You pass Jupiter with its great storms, and Saturn with its elegant rings. And still you keep going, farther and farther from the warmth and light of our star, until the Sun becomes merely the brightest point in an infinite field of smaller lights. Out here, at the edge of the solar system's bright neighborhood, a faint blue sphere hangs in the absolute darkness, not gleaming like Venus, not rusty like Mars. Blue, the color of deep water on a night when the moon is full and the world is still. This is the experience we are going to share together in this documentary, a slow, patient exploration of Neptune's most soothing qualities, the facts and features that allow us, from our small and distant world, to find something approaching peace in the contemplation of that great blue wanderer. If you would like to return again and again to Neptune's calm blue distance, to drift slowly through the solar system's most tranquil mysteries, I invite you to subscribe so you can discover more of these relaxing cosmic journeys whenever you need them. Now, as we begin our approach toward that world, let us first understand what we are moving toward. The distance itself is worth sitting with for a moment. Neptune orbits at an average of 2.8 billion miles from the Sun. Try to hold that number in your mind. 2.8 billion miles. If you could travel at the speed of light, if you could move faster than anything that has ever been measured in the universe, it would still take you 4 hours and 14 minutes just to reach Neptune from the Sun. Light, the fastest thing we know of, takes longer to reach Neptune than it takes many of us to finish a workday. And yet Neptune is there, patient and constant, completing its long orbit. It has been moving through its great elliptical path for the entire history of the solar system, for 4.5 billion years, circling the Sun with a slowness and regularity that is almost meditative in its reliability. The temperature at Neptune's cloud tops hovers around -220 degrees Fahrenheit, a cold so profound that it is difficult for the human mind to truly grasp. The molecules of gases that make up Neptune's visible surface, the methane, the hydrogen, the helium, move slowly in this deep freeze, creating patterns and swirls that seem almost to drift rather than race. The color, that remarkable deep blue, comes from the methane in Neptune's atmosphere. Methane absorbs the red and yellow wavelengths of sunlight, allowing the blue to scatter and reflect back towards space. And so, from a great distance, Neptune appears to us as something like a jewel, a precious stone that has been polished by eons of solar wind and cosmic radiation. The blue is not bright or vivid, but rather deep and soft, like looking through a window into still, clear water on an autumn evening. It is a blue that suggests quiet, that implies calm, even as tremendous violence churns beneath that serene exterior. As we drift closer in our imagination, the sphere before us grows larger, resolving from a distant point into a visible world, 4 times wider than Earth, 17 times more massive, large enough that you could fit 58 Earths inside its volume with room remaining. And yet this enormous world moves through space with an almost unhurried grace, completing a single orbit around the Sun in 165 Earth years, 1 Neptunian year. A child born during the discovery of Neptune would not yet have lived to see that planet return to the same position in its orbit. The entire span of recorded human history, from the earliest written words to this very moment, represents only a small fraction of a single year on Neptune. There is something deeply humbling about that fact, something that naturally slows the mind and invites a kind of patience. The darkness surrounding this world is almost absolute. The sun, though still present, is so distant and so small from Neptune's perspective that it provides only a faint illumination, barely enough to cast shadows on the world's cloud formations. It is the kind of dimness you might experience on Earth just before true dawn, in that liminal time when the world is no longer quite night but not yet day. In that twilight, Neptune exists, blue, distant, turning slowly in the vast expanse. And from this vantage point, held in the imagination at the edge of the solar system, with the vast darkness all around and that gentle blue sphere before us, we begin to understand why Neptune might offer us a particular kind of peace. Not because it is small or harmless, but because its very distance, its profound isolation, and its unhurried motion through the cosmos speak to something in us that yearns for slowness, for patience, for a respite from the frenetic pace of our solar system's inner regions. Neptune teaches us, merely by existing as it does, that there is a kind of beauty and tranquility in the margins of our cosmic neighborhood, in the quiet places where light moves slowly and time seems to move even more slowly still. And so we float here at the edge of everything we know, 30 times farther from the sun than Earth, where light takes 4 hours to reach us and silence settles like snow on a world we have barely touched. It is here, in this distant blue quietude, that we might pause and ask ourselves a simple question. Would you want to return to this place again? Not in the frantic manner of discovery or urgent scientific need, but rather as one returns to a familiar room at evening, knowing that calm awaits you there. There exists a particular comfort in distant planetary knowledge, the kind of knowledge that asks nothing of us but our attention and our willingness to imagine. Neptune offers this gift repeatedly, a world so far away that it seems almost removed from our ordinary concerns, and yet so comprehensible in its beauty that we cannot help but wonder what else we might find if we allowed ourselves to journey slowly through the cosmos, pausing at each world as though visiting old friends. Each planet holds within it a different kind of peace. Earth is the peace of familiarity. Venus teaches us through contrast and caution. Mars speaks to the pilgrim in us. But Neptune is the peace of distance itself, the calm that comes from stepping back and seeing how very small our urgencies truly are. If these slow explorations of distant worlds have found their way into your rest, if the image of Neptune's deep blue has begun to settle into your mind as something you would like to return to again and again, then perhaps you might consider subscribing to Journeys Through the Solar System, these patient, unhurried travels where we move from world to world, gathering the quiet facts that soothe rather than startle, that expand our sense of wonder without demanding anything of us but presence. Each world waits for us in its own way. Each one has its own story to tell in the darkness, and Neptune, always, remains there at the edge of everything, patient and blue and impossibly far away, ready to receive us whenever we wish to drift back into its embrace. The invitation, then, is not urgent. It is not a command or a demand for your immediate allegiance. It is simply an offer to return here, to go deeper, to let the solar system unfold before you as you rest, one world at a time, each one becoming a familiar landmark in your nocturnal wanderings. There is no pressure in distance. There is only the steady pull of curiosity and the quiet knowledge that some of the most important journeys are those we take while barely moving at all. For now, though, our focus narrows further still, back through time, back to the moment when Neptune did not yet exist in the human mind, or rather, when it existed only as a mathematical ghost, a phantom presence calculated into being before any eye had ever seen it, before any telescope had ever pointed in its direction. How does a world come to exist in mathematics before it exists in light? How do we know something we have never observed? This is the story that awaits us, the triumph of human calculation, the moment when the invisible became visible, when pure reason and pencil strokes on paper led astronomers across the darkness to find a world that was already waiting, patient and blue, for someone to finally recognize its presence in the vast and indifferent sky. There exists in the quiet history of astronomy a moment of profound elegance, a moment where human minds reached into the darkness not with telescopes, but with pure mathematics. Long before Neptune was ever seen through a lens, before light from that distant world touched a human eye, two mathematicians working separately in different countries arrived at nearly the same conclusion about something invisible, something that should not have existed according to everything astronomers believed they knew. And in that discovery lies one of the most soothing truths about science itself, that sometimes the universe reveals its secrets not through accident or observation, but through the inexorable logic of numbers. In the early 1800s, astronomers had been watching Uranus, that pale blue-green orb that itself had been discovered barely more than half a century earlier. But Uranus moved in a way that troubled them. Its path through the heavens did not quite align with what the laws of motion predicted. The planet wandered slightly, ever so slightly, from where Newton's mathematics said it should be. To the casual observer, this might seem like a minor discrepancy, a small uncertainty lost in the vast indifference of space. But to mathematicians, this tiny deviation was a question that demanded an answer. What if, they began to wonder, there was another body out there, another planet perhaps, whose gravity was gently tugging at Uranus, pulling it slightly off course? What if the perturbations they observed were not errors in measurement or gaps in understanding, but rather the mathematical echo of a world they could not yet see? In France, a brilliant mathematician named Urbain Jean-Joseph Leverrier pursued this riddle with disciplined intensity. He gathered all available observations of Uranus's position over decades, spread them across pages of calculations, and began to work backward through the mathematics of gravitation. Where would another planet need to be? How massive would it need to be? What would its orbital path look like? The equations flowed from his pen, layer upon layer of computation, building toward an answer that seemed almost impossible. There was a planet out there, waiting to be found, and he could tell the world exactly where to look. Across the Atlantic, largely unaware of Leverrier's work, a young mathematician named John Couch Adams at Cambridge University was pursuing nearly the same path. Adams, too, had examined the movements of Uranus. Adams, too, had worked through the complex mathematics of gravitational perturbation. And Adams, too, had arrived at remarkably similar conclusions about the existence and location of this unseen world. There is something profoundly moving about this convergence, this moment when two brilliant minds working separately arrive at truth through logic alone. When Leverrier published his predictions in 1846, he did more than simply announce that a planet existed. He provided specific coordinates, a location in the sky where this invisible world should be found. This was not vague speculation. This was mathematics, speaking with the authority of celestial mechanics. And when astronomers pointed their telescopes toward the location Leverrier had predicted, there it was, Neptune. Not quite at the exact spot he had calculated, the observation was off by about 1 degree, but close enough that the discovery sent ripples of amazement through the scientific community. What had occurred was something almost too perfect to believe. Human minds, using nothing but mathematics and the accumulated observations of earlier astronomers, had effectively reached out beyond the furthest known planet and plucked a new world from the darkness. The triumph lay not in chance observation or luck, but in the patient, rigorous application of logic to imperfect data. Neptune had not been found through a telescope pointed randomly at the sky. Neptune had been predicted into existence. There is a quieting quality to this story, isn't there? A reminder that understanding often comes not from frantically searching, but from sitting still with a problem, turning it over in your mind, letting the mathematics speak. In a world that celebrates the sensational moment of discovery, the flash of insight beneath the telescope, this quiet triumph of prediction and patience offers something deeper. It suggests that the universe obeys rules so fundamental, so unforgiving and so elegant, that a human being sitting at a desk with paper and pencil can deduce what lies beyond the horizon of human sight. The cosmos is not random, it is not hidden, it is written in the language of mathematics, and those patient enough to learn that language can read it like an open book. When the time came to name this newly discovered world, the astronomers and mathematicians who had summoned it from the darkness through pure calculation looked for a name worthy of such a cosmic revelation. They might have chosen something that spoke to its mathematical origins, or its distant blue light, or the sheer audacity of finding an invisible giant through equations alone. But instead, they turned to Rome, to the ancient pantheon, to a god as old as human civilization itself. They chose Neptune, the god of the sea, the deity who ruled over vast oceans, over calm waters and gentle tides, over the deep blue tranquility of Earth's own seas. A name that, even now, carries with it the image of serenity. Neptune the god, typically depicted with his trident, master of waters that lap against shores in peaceful rhythm, an embodiment of aquatic calm and orderly flow. There is something profoundly, almost poetically ironic in this choice, when you consider what Neptune the planet actually is. Neptune is not calm at all. Neptune is not serene. Neptune is, in fact, one of the most violent and tempestuous worlds in our entire solar system. Its atmosphere churns with winds that reach speeds of nearly 2,000 kilometers per hour, the fastest winds ever observed anywhere in the solar system. These are not gentle currents. They are not the peaceful movement of water caressing a beach. They are ferocious, relentless gales that tear across the planet's surface in patterns of extraordinary chaos and power. The winds of Neptune move with such tremendous velocity that they could circumnavigate the entire planet in just 18 hours. If you were standing on Neptune, which of course you cannot, for there is no solid surface, you would be swept away instantly. You would cease to exist as a coherent form within milliseconds. And yet, somehow, this angry world wears the name of a god of peaceful waters. Perhaps the astronomers who chose this name were thinking of Neptune's color. The planet presents itself to our eyes, and to our instruments, as a gorgeous deep blue. A blue so rich, so profound, so utterly mesmerizing, that it does indeed evoke the image of Earth's oceans. When Voyager 2 transmitted its first close images of Neptune back to Earth, scientists and civilians alike were struck by the overwhelming blueness of it. The kind of blue you see in the deepest parts of the ocean, in those places far below sunlight, where pressure is absolute and mystery reigns eternal. It is a calming color, a color that speaks to serenity, and the methane in Neptune's upper atmosphere, which scatters red light and absorbs blue light, creates this tranquil appearance. So perhaps in naming the planet Neptune, the namers were honoring not its behavior, but its appearance. They saw an ocean-blue world and gave it the name of the sea's god, understanding that names, like first impressions, often capture what we see rather than what truly is. But there is a deeper irony here, and it is worth sitting with for a moment as we drift through this contemplation. Throughout human history, we have named things, places, ships, children, stars, not necessarily for what they are in their essence, but for what we hope them to be, or what they resemble from a distance, or what we wish them to represent in our collective imagination. We looked at a distant blue world that we found through mathematics, and we called it after calmness, after water, after the god of the sea. In doing so, we projected onto it a quality that it does not possess, a nature that contradicts its reality. And perhaps that is one of the beautiful things about human naming. We are creatures who understand metaphor. We are beings who can look at a raging storm and call it serene, not because the storm is serene, but because we understand that serenity and beauty are not the same thing. A storm can be beautiful. A violent wind-swept giant of a world can be breathtaking. A place of absolute chaos can still be worthy of reverence and wonder. Neptune, the planet, does not know its own name. It does not experience the irony or feel the contradiction. It simply continues its slow, relentless orbit around the sun, buffeted by winds of tremendous velocity, its methane-rich atmosphere creating that deep, mesmerizing blue that drew our eyes and inspired our poetic naming instinct. The name Neptune reminds us of something, though. It reminds us that when we encounter beauty and mystery in the cosmos, we respond with the language of poetry, of mythology, of ancient stories. We do not name a world after mathematics, even though mathematics is what found it. We do not name it after its violent nature, even though violence is what defines much of its character. Instead, we name it for what it makes us feel, for the sensations it evokes, for the sense of profound ocean blue serenity that washes over us when we contemplate something so distant, so unknown, so utterly separate from our small experience on Earth. In that moment of naming, we were not describing Neptune, we were describing ourselves. We were revealing what moves us, what calms us, what draws us toward wonder. And perhaps that is the greatest irony of all, and also the greatest truth. Imagine standing on a beach at the edge of a vast, still ocean, and then imagine that ocean is the entire distance between Neptune and the Sun. Light itself takes 4 hours and 20 minutes to cross that gulf. 4 hours. The photons that left our Sun this morning won't reach Neptune's atmosphere until evening arrives on Earth, and when they do, they'll deliver barely more than 1/600th of the warmth and brightness that reaches our own world. Neptune orbits at a distance of roughly 2.8 billion miles from the Sun, so far that our star has become something more like a very bright star in the sky, rather than the overwhelming furnace we know. The Sun at Neptune appears about 900 times smaller to the eye than it does from Earth, which is to say, it appears as little more than an exceptionally brilliant point of light against the black, cold emptiness. But distance alone doesn't quite capture the true strangeness of Neptune's isolation. The real revelation emerges when you consider what that distance means for time. Neptune moves through its orbit with an almost incomprehensible slowness, taking precisely 165 of our Earth years to complete a single lap around the Sun. 1 Neptunian year equals 165 human years. That single statistic, when you pause with it for a moment, begins to reshape how you think about motion itself, about seasons, about the meaning of a year. In the time it takes Neptune to complete one orbit, your great-great-great-grandparents were born, lived full lives, and returned to dust. The American Revolutionary War, the Industrial Revolution, the birth of photography, the invention of the telephone, the rise of aviation and space exploration, all of human modernity from the perspective of a person watching Neptune's orbit would unfold like the opening scene of a flower in springtime, unfolding over the span of what Neptune would call merely the first quarter of a single year. Consider the profound implications of this temporality. When Neptune was last at its current position in its orbit around the Sun, it was the year 1845. Cameras had barely been invented. Charles Dickens was publishing his novels to Victorian audiences. The world had not yet seen a photograph of itself. Thomas Edison had not yet been born. The world that Neptune knew in 1845 was so fundamentally different from the world it knows now that the transformation feels less like change and more like the replacement of one entire reality with another. And from Neptune's perspective, this wasn't a century of change, it was merely the beginning of a single year. The planet moves so slowly through space that astronomers tracking its position across the 19th century and into the 20th had to develop entirely new techniques just to detect its gradual progress. So subtle was the movement across the background of stars. The slowness of Neptune's orbit creates a strange inversion of our usual experience of time. On Earth, we divide our year into seasons, into months and weeks and days, each unit of time reflecting the planet's position in its orbit around the Sun. But Neptune's orbit is so extended that the planet's distance from the Sun varies across decades in ways that Earth's seasons vary across months. Neptune has poles that experience approximately 41-year-long seasons. Imagine winter in the Arctic Circle lasting 41 years. Imagine spring taking 41 years to arrive. Imagine the psychological weight of waiting for summer while 4 entire human generations grow old and pass away. The atmosphere of Neptune, which we'll explore further as we travel deeper into this blue world, may only show the fullest expression of its seasonal changes once every 165 years, which means humanity has never actually witnessed a complete Neptunian year. The records we have of Neptune are fragmentary, like watching a single sunrise and then being asked to describe what the entire cycle of day and night must be like. There's a meditative quality to contemplating such vast timescales, a gentle dissolution of the usual urgency we feel about our own brief years. When you stand back far enough to see Neptune and its orbit, and its incomprehensible patience moving through space, you begin to sense something of the true scale of our cosmic neighborhood. Neptune doesn't rush. Neptune doesn't scramble to complete its circle around the Sun. Neptune moves with the eternal, unhurried grace of something so massive and so distant that no force in the solar system could hurry it along any faster than the laws of physics permit. It is, in a very real sense, one of the slowest dancers in the solar system, waltzing at a tempo so deliberate that we can barely detect the movement of its feet. And so we arrive at the question of Neptune's true vastness, a dimension that our minds must reach toward to comprehend. If you were to stand on Earth's surface and imagine a sphere large enough to hold our entire world inside it, and then imagine that same sphere fitting within Neptune not once, but 63 times over, you would only begin to approach the staggering geometry of this distant giant. Neptune's equatorial diameter stretches nearly 49,000 kilometers across the void, which is to say that if you could somehow arrange 63 Earths in a perfect line, Neptune would still dwarf that procession. 4 times wider than the planet you inhabit, 4 times the span of all the oceans and continents and mountains and valleys you have ever known or ever will know, compressed into a single comparison of scale. There is something almost comforting in this vastness, isn't there? The human mind, when faced with such immensity, sometimes releases its grip on urgency, on smallness, on the ordinary weight of daily concern. When you understand that Neptune is large enough to contain more than 58 billion Earths within its volume, if you were somehow to hollow it out and begin filling it with our home world, like marbles dropped into an ocean, a certain perspective finds its way into the thinking mind. The worries that seem so immediate, so pressing in our waking hours, begin to feel less like mountains and more like dust settled on a distant shore. And yet, Neptune is not the largest planet in the solar system. Jupiter, nearly 11 times wider than Earth itself, still exceeds Neptune in sheer dominion, but Neptune possesses something different from Jupiter's violent, roiling grandeur. Neptune is vast without being overbearing. It is immense without aggression. It turns in its solitary orbit, nearly 3 billion kilometers from the Sun, indifferent to the cosmic drama unfolding in the inner regions of the solar system, content in its blue and distant sovereignty. The composition that creates this mighty sphere, that gives Neptune its physical form and substance, is not solid ground as we understand it on Earth. There is no crust to stand upon, no bedrock beneath your feet. Instead, Neptune exists as a great rolling ocean of gases and liquids, a world in constant motion, without any true surface in the way we imagine surfaces to be. At the cloud tops, where the outermost wisps of Neptune's atmosphere meet the vacuum of space, temperatures descend to a chilling -220 degrees Celsius. This is colder than the vast majority of our understanding permits us to grasp comfortably. To put it in perspective, if you were to venture outside our protective atmosphere and expose yourself to such cold, you would become a frozen statue almost instantaneously, your very breath crystallizing before it left your lungs. Yet as you descended through layers and layers of Neptune's atmosphere, as you sank deeper into its depths, a journey you could never actually take, of course, but which we might imagine in the quiet stillness of contemplation, the pressure would increase with each kilometer. The weight of all that gas above you would press down with a force beyond measure, compressing the atmosphere into denser and denser states of being, until the distinction between what we call gas and what we call liquid began to blur and fade. And beneath this transition, beneath this veil where states of matter lose their clear definitions, lies the true mystery of Neptune's interior. Hydrogen and helium, the lightest elements, the most abundant substances in the universe, form the outer layers of Neptune's being, creating its visible face, its great blue sphere of apparent calm and gentleness. But what lies beneath them? What happens when you push through those gases and enter the regions where pressure becomes so extreme that the physics we observe on Earth no longer apply in quite the same way? That is the question that draws our imagination downward, that pulls our consciousness into the depths of this distant world, inviting us to wonder about what hidden realms exist beneath that serene blue surface, hidden from all observation, from all direct knowledge, existing only in the realm of theory and mathematical prediction and careful scientific speculation. If you could step beyond the void, beyond the crushing cold that shrouds Neptune's domain, and drift instead through the planet's outermost veil, you would encounter something far simpler and far more profound than the swirling storms below. The atmosphere that surrounds Neptune, that thin blue envelope we see from Earth, or from the distant vantage of our spacecraft, is composed almost entirely of the lightest elements in the cosmos: hydrogen and helium, the very first breath of the universe, still floating here, still dancing in the place where it settled billions of years ago. Approximately 80% of Neptune's atmosphere is hydrogen, the smallest, the lightest, the most abundant element in all of creation. Helium comprises roughly 19%, that noble gas born in the hearts of dying stars, inert and patient. And then there is that remaining fraction, that slender thread of something different, something that would transform everything we see when we look upon Neptune's face: methane. In the grand sweep of the solar system, methane is a modest compound. 3 hydrogen atoms cling to a single carbon atom, a simple embrace, a molecular whisper. And yet, when sunlight, that diminished and precious light that travels 5.5 hours to reach Neptune's orbit, when that distant sunlight encounters methane in the upper atmosphere, something remarkable occurs. Methane has an extraordinary appetite for the color red. It hungers for those longer wavelengths, capturing them, swallowing them, holding them within its molecular structure. And what bounces back? What escapes and returns toward our eyes? The blue, the green, the colors we associate with deep water and tranquility, and the vast, unfathomable depths of oceans we will never fully explore. This is why Neptune appears to us as it does, crowned in that ethereal, otherworldly blue that seems almost painted onto the darkness. It is not the blue of liquid water. Neptune's atmosphere contains precious little actual water, but it is the blue of a gem that has been colored by impurity, refined by chemistry, into something arrestingly beautiful. The methane traces wind through the hydrogen and helium, and as they circulate and drift and tumble in the upper regions of the atmosphere, they perform a kind of molecular alchemy, transforming what could have been a colorless world into something that catches the imagination. The abundance of methane in Neptune's atmosphere is puzzling in its own way, when you consider the greater picture. If you compare Neptune to its neighbor Uranus, which orbits closer to the Sun and shares many fundamental similarities, both being ice giants of comparable size and composition, Uranus too contains methane. And yet Uranus appears greenish-blue, muted, less vibrant. Why should Neptune's blue run so much deeper, so much richer, so much more inviting to the eye? Scientists have proposed that additional layers of cloud, or perhaps a distinct haze suspended higher in the atmosphere, might scatter and filter the light differently. These clouds themselves may be composed of substances that have condensed from the methane and ammonia vapors, frozen crystals of those compounds, particles of ice drifting through the darkness like infinite snowflakes falling upward, or perhaps falling downward, depending on the violent winds that shape that alien sky. As you descend deeper through the methane-rich layers, as you imagine yourself sinking through clouds of hydrogen and helium, the methane becomes more and more prevalent. Its concentration increases steadily with depth, a gradient of presence, a spectrum of change. The cold, unimaginably cold, approaching -200 degrees Celsius in the upper atmosphere, keeps everything in gaseous form. Methane drifts as vapor, invisible in the depths, yet present everywhere, woven through the tapestry of wind and pressure. And perhaps the most soothing aspect of this composition, the element that brings us closest to understanding Neptune's gentle character, is the remarkable stability of these elements. Hydrogen, helium, methane, they are not volatile in the way that earthly storms are volatile. They do not burn, they do not corrode or decay in the presence of one another. They are, in a sense, perfectly suited to one another, locked in an embrace that will persist for eons. The hydrogen will remain hydrogen, the helium will remain helium, the methane will continue its slow dance, capturing red light and releasing blue, painting the distant world in colors that speak to something deep within our sense of wonder and calm. Consider for a moment what it means that we know this, that from a distance of nearly 3 billion miles, across the void, through instruments and mathematics and careful observation, we have discerned not merely that Neptune is blue, but why. We understand the mechanism, we comprehend the chemistry, we have traced the photons backward and forward, understanding how they interact with methane molecules, how they are absorbed and scattered. This knowledge itself possesses a kind of serenity, a settling quality, the knowledge that even in the most distant, most alien places, we can reach out with our minds and perceive truth. Beneath that serene blue surface, Neptune guards a secret that physicists have long puzzled over in quiet wonder. We cannot see into it. No light reaches there. No spacecraft has ever descended through those upper layers to touch what lies below, and perhaps none ever will. And yet, through mathematics and inference, through the patient work of observation and theory refined across decades, we have come to understand something remarkable about what waits in that absolute darkness. The interior of Neptune is not what one might first imagine. There is no solid core sitting at the planet's heart like a marble at the bottom of a sphere. Instead, what exists there, what our best understanding suggests, is something far more unusual and, in its own way, far more beautiful. Beneath the hydrogen and helium atmosphere, beneath the methane-rich clouds that paint Neptune its tranquil blue, the pressure begins to intensify. The weight of all those gases pressing down from above creates conditions that grow almost incomprehensible to the human mind. Imagine descending into that darkness. The temperature rises, the pressure mounts, and somewhere, we believe perhaps a quarter or third of the way down toward the planet's center, a transformation occurs. The very substances that exist as gases in our world begin to behave differently. Water, ammonia, methane. These familiar molecules, the stuff of oceans and air on Earth, are crushed and heated until they exist in a state that has no simple name in ordinary language. Scientists describe it as a mantle of ices, but this word carries a misleading connotation. These are not frozen solids as we know them. They are not hard and brittle. Instead, imagine a kind of planetary slushy, a dense, hot, electrically conductive fluid made of water molecules and ammonia compounds and methane, all jumbled together under pressures millions of times greater than what exists at the surface of Earth. This slushy mantle is not static, it moves, it swirls. Deep within Neptune, this ocean of exotic ice, if one can still call it ice, likely plays a crucial role in generating the planet's magnetic field. The movement of these electrically charged fluids, heated from below and pressurized from above, creates currents that spin and interact in ways that produce magnetism. It is a gentle reminder that ice, under the right circumstances, becomes something fluid and alive and dynamic. What lies beneath this mantle remains even more mysterious. At the very heart, there may be a core of rock and metal, though we cannot know its true composition with certainty. Some theorists propose it is relatively modest in size, no larger than a few Earth masses. Others wonder if it might be more substantial. The truth is that Neptune keeps its deepest secrets well. The pressures at its center may exceed 5 million times what we experience standing on Earth's surface. The temperatures may soar to thousands of degrees. In such conditions, matter behaves in ways that laboratory experiments can barely approximate, let alone fully illuminate. What is particularly calming to contemplate, in a strange way, is how little certainty we possess about Neptune's interior, and yet how much we can infer. We know its mass, we know its magnetic field, we understand gravity's laws and how pressure and temperature change with depth. From these pieces, like a vast jigsaw assembled in the mind, we construct our picture of that hidden world. It is not complete, it may never be complete, but it is built on reason and observation, on the accumulated knowledge of centuries, and it speaks to something profound about human curiosity, our drive to understand even those places we may never touch. The slushy mantle itself, this ocean of transformed ice, represents one of the gentler mysteries. It is not violent in the way some planetary interiors are. Jupiter's core, some theories suggest, may be tumultuous and chaotic. Saturn's interior may roil with convection, but Neptune's interior water-ammonia mantle, compressed and heated though it is, seems almost serene in comparison, a realm of strange pressures and exotic states of matter, yet fundamentally stable, fundamentally patient. It has existed for billions of years, and it will continue to exist, cycling slowly, endlessly, in the silence and darkness 4 billion kilometers from the distant sun. One might wonder, in the deep hours of contemplation, what other secrets lie hidden in the interiors of distant worlds. How many Neptunes exist out in the cosmos, each with their own hidden mantles of exotic materials, their own mysterious cores? Neptune invites us to consider that the most profound mysteries are often not written in light and color across a visible surface, but rather exist in the darkness below, in the places we cannot see, in the slow transformation of matter under conditions so extreme that they exist nowhere in human experience. And there is something deeply restful in accepting that some things will remain hidden, that knowledge has limits, and that the universe can still hold mysteries that inspire our wondering long after our eyes grow heavy and the world begins to drift away. Deeper still into Neptune's interior, past the swirling methane clouds and the hydrogen-helium envelope, the pressure begins to transform matter itself in ways that seem almost like myth, and yet the science here is as real as stone. There exists, in the depths of this distant world, a phenomenon so extraordinary that it has captured the imagination of both astronomers and physicists: the possibility that carbon, that most elemental of all creative materials, might crystallize into diamonds under the immense weight of Neptune's atmosphere and gravitational pull. Consider what happens when you descend through the layers of a gas giant. The pressure does not increase in gentle steps. It builds catastrophically, crushing down with a force that has no parallel in human experience. At certain depths within Neptune, somewhere beneath that blue veil of methane clouds, the temperature soars to thousands of degrees, hot enough that carbon atoms, those same atoms that make up the graphite in your pencil and the diamonds in a wedding ring, might begin to rearrange themselves. Under pressure so extreme that it fundamentally rewrites the rules of chemistry, carbon atoms are forced together into their densest, hardest crystalline structure. And here is where the imagination truly takes flight, where the boundary between what we know and what we theorize becomes delightfully blurred. Scientists have proposed that in Neptune's depths, diamonds might actually form and then fall, drift downward through layers of liquid water and ammonia and methane, descending through an ocean of exotic materials that could never exist on Earth. Picture, if you can, a rain of diamonds, not raining from clouds above, but crystallizing in the crushing darkness, and slowly, inexorably, sinking toward whatever core might exist at Neptune's hidden center. These would not be diamonds as we imagine them in jewelry boxes or in engagement rings. They would be enormous, warped by the pressures that formed them, existing in states of matter that have no stable form anywhere else in the known universe. The theory itself emerged from laboratory experiments conducted here on Earth, where scientists used diamond anvils and extreme pressure chambers to recreate the conditions that might exist on distant planets. When carbon is compressed to pressures of thousands of gigapascals, numbers so large they almost cease to have meaning, it does indeed form diamond. And when those conditions resemble what we believe to exist on Jupiter and Saturn and Neptune, researchers began to wonder, might this actually be happening right now, at this very moment, in those distant blue worlds? For Neptune specifically, the scenario becomes even more intriguing. The planet's interior is thought to contain not just solid carbon, but also hydrogen and helium mixed with ice compounds, water ice, ammonia ice, methane ice, substances that exist as solids only under such tremendous pressure. Add to this the ongoing process of planetary differentiation, the natural sorting of heavier elements toward the center, and suddenly you have a kind of infernal sorting mechanism at work, where diamonds might slowly migrate downward through layers that are themselves almost inconceivable in their density and temperature. Now, it must be said with appropriate humility that much of this remains speculation. We have not, and likely never will, send instruments deep enough into Neptune to verify these ideas with absolute certainty. The pressures are too extreme, the distances too vast, the engineering challenges perhaps insurmountable. What we have instead are the calculations of physicists, the results of high-pressure experiments, and educated guesses based on what we understand about the composition of ice giants and the behavior of matter under extreme conditions. Yet there is something profoundly calming about this possibility, isn't there? The idea that far away, in that deep blue world that orbits so slowly around the distant sun, within layers of material we can barely fathom, one of Earth's most precious substances might be forming and falling and accumulating in the darkness. It speaks to the generosity of the universe, to its creative excess. It reminds us that beauty and wonder don't require an observer. They happen whether we're watching or not. There is also a strange comfort in the notion that Neptune, despite its ferocious reputation, a place of violent storms and crushing pressures, might secretly contain such treasure. The planet, in a sense, wears a mask. From a distance, it appears as nothing more than a serene blue sphere, painted with methane's color, rotating slowly in the void. But beneath that mask, if our theories are correct, extraordinary transformations are taking place. Carbon is becoming diamond. Matter is being reformed according to rules we are only beginning to understand. The planet is both violent and generative, brutal and beautiful, all at once. This is the wonder of Neptune, really, that we can stand on Earth, use mathematics and physics and our imagination to theorize about what might be happening in a world so distant that light takes over 4 hours to travel from the sun to its surface. We construct these images not from direct knowledge, but from careful reasoning, from experiment, from the accumulated understanding of how the universe works. And in doing so, we expand our sense of what is possible, of how extravagantly the cosmos creates and transforms, and hides its treasures in the dark. Yet there exists within this tranquil blue sphere a violence so extreme that it seems almost impossible, a paradox that sits at the very heart of Neptune's strange beauty. The winds that encircle this distant world are the fastest in our entire solar system, a fact that remains deeply unsettling when you consider the planet's serene appearance from afar. Speeds of 2,100 kilometers per hour have been measured in Neptune's upper atmosphere. Winds so violent they dwarf the fiercest hurricane ever recorded on Earth. And yet, from the vantage point of our distant telescopes and space probes, Neptune presents itself as perfectly calm, perfectly blue, almost meditative in its stillness. How is it possible that such destructive power churns beneath a surface so gentle and so unchanged? The mystery deepens when you consider what drives these winds. Neptune is vastly farther from the sun than Earth, so distant that the sunlight reaching its cloud tops is reduced to little more than a pale blue glow, a faint caress of warmth so minimal that it barely registers against the planet's own internal heat. And yet somehow, paradoxically, those distant rays seem to trigger wind patterns of extraordinary ferocity. The energy driving these storms is not primarily solar, as it is on Jupiter or Saturn, or even here on our own world. Much of Neptune's wind power appears to come from the planet's own interior, from the slow release of primordial heat left over from Neptune's formation billions of years ago. Heat still trapped and still seeping outward through the dense layers of ice and gas. This internal furnace, this hidden engine of motion, powers atmospheric dynamics, so violent that they seem almost impossible for such a distant, cold world to sustain. These winds do not blow uniformly in a single direction. Instead, they spiral and swirl in the most intricate patterns, creating enormous storm systems that drift across the planet's face like living things. Vast tempests of methane clouds and crystalline ice particles caught in these astronomical maelstroms. The Great Dark Spot, which we will return to in a moment, was perhaps the most famous of these storms, a hurricane-like structure so enormous that it could swallow Earth entirely, yet it drifted and shifted and ultimately vanished from sight, only to perhaps reappear elsewhere in Neptune's restless atmosphere. Smaller storm systems appear and disappear with what seems like capricious regularity, bright white clouds flaring up briefly before fading back into the blue, as if Neptune is slowly breathing out its internal turbulence into the cosmos. What makes this wind phenomenon even more remarkable is that these speeds seem to vary with latitude, much as they do on Earth, but in ways that still perplex the scientists who study them. The equatorial winds blow in one direction at certain speeds, the mid-latitude winds in another, the polar winds in yet another pattern entirely, creating a complex symphony of motion that is barely visible to our instruments and our eyes. The wind shear between adjacent layers of atmosphere is so extreme that it seems almost cruel. Adjacent bands of air moving in opposite directions, or at vastly different speeds, creating a kind of atmospheric friction that should theoretically dissipate these winds over time, yet they persist. They seem almost immortal, these phantom hurricanes on Neptune's distant face. And there is something almost restful about contemplating this paradox, is there not? Here is a world so far from us that it takes light more than 4 hours to reach it from the sun, and yet it rages with interior passion, with violence and motion that we can barely see and only dimly understand. The blue color that soothes us when we gaze upon Neptune from afar masks something far more turbulent, far more dynamic than we might assume. It is a reminder that appearance and reality are often profoundly different, that serenity can be a mask worn by tremendous power, and that the universe's most peaceful-looking places might be among its most tempestuous. Neptune sits in the darkness, serene and blue, while 1,000 storms turn and writhe beneath its pale facade, indifferent to our observation, indifferent to our attempts to comprehend its mysteries. The wind patterns themselves seem to follow no easy formula, no simple explanation that might settle our curiosity. Mathematical models can approximate them, can predict where these storms might drift and how they might evolve, but prediction remains imprecise, tentative. Neptune guards its secrets carefully, revealing only glimpses of the truth to those who seek it. And in that guarding of secrets, in that refusal to be easily known, Neptune seems almost intentional, almost alive with a kind of patient intelligence that we can barely fathom. And as we draw closer to Neptune's face, toward the place where its atmosphere swirls in patterns only recently revealed to human eyes, there exists a phenomenon that troubled astronomers and delighted them in equal measure. A storm so vast, so darkly defined, that when the Voyager spacecraft first captured its image in 1989, observers could scarcely believe what they were seeing. It was called the Great Dark Spot, and it remains, even now, one of the solar system's most bewildering atmospheric mysteries. Picture, if you will, the moment of discovery. Voyager 2, that tireless explorer that had journeyed for 12 years across the void, reached its closest approach to Neptune and turned its cameras toward the planet's roiling clouds. There, at roughly 40 degrees south latitude, swirled a vast tempest, a storm system so enormous that it could have swallowed several Earths whole. The spot itself was dark, a deep charcoal against the pale blue of the surrounding atmosphere, edged in white clouds like a great eye watching the cosmos. It drifted slowly, turning with the planet's rotation, and yet moving independently across the face of Neptune in ways that seemed almost willful, almost aware. Astronomers were transfixed. Here was direct proof of Neptune's turbulent nature, visible confirmation of the violent weather they had inferred from wind speeds and atmospheric disturbances. The Great Dark Spot became the focal point of every study, every analysis. It seemed stable, it seemed permanent, a fixture in Neptune's upper atmosphere that would endure, perhaps, for centuries to come. And then, impossibly, it vanished. By 1994, only 5 years after Voyager's departure, when the Hubble Space Telescope turned its gaze toward Neptune, the Great Dark Spot had utterly disappeared, gone without trace. Where once there had been a storm large enough to rival Jupiter's Great Red Spot in spectacle and presence, there was now only the pale, swirling blue of Neptune's clouds, unmarked and serene. The scientific community was left holding a profound and troubling question. How could a storm so vast, so definitively observed and measured, simply dissolve into the planet's atmosphere as though it had never been? The leading theories emerged slowly, from careful study and gentle speculation. Perhaps the spot had been unstable from the start, its dark color not the product of solid matter or long-lived circulation patterns, but rather a temporary darkening of the clouds, caused by particles drawn up from deeper layers of the atmosphere. In this view, such spots might be transient things, remarkable but fleeting, gifts of observation rather than permanent features. The spot may have dissipated as those particles settled again into the depths, or as new atmospheric layers rose up to obscure them, restoring the generic blue to Neptune's face. There is something almost poignant in this thought. We saw something momentous, something rare and vast, and we were permitted only a brief glimpse before it returned to invisibility. It was not unlike catching sight of a rare creature in a deep forest, seeing it with absolute clarity for just long enough to know that we had truly seen, and then watching it slip back into the undergrowth, leaving us uncertain whether it will ever be found again. Yet the story does not end in absence. In the years that followed, astronomers detected new dark spots appearing on Neptune, smaller, more fleeting perhaps, but present nonetheless. It seemed that the planet was not without its great storms, merely without that one particular and famous one. The dynamics of Neptune's atmosphere, it became clear, allowed for the formation of such temporary structures, regions where the circulation and composition of the clouds created visible disturbances that might last for years, or might dissolve within months. The great dark spot, in this interpretation, was simply one manifestation of a process that continues still, creating and dissolving storms in a ceaseless, invisible dance. What strikes us, as we consider this mystery, is how little we truly know about the interior workings of distant worlds. The great dark spot appeared, was observed for mere moments in cosmic time, and then was gone, leaving behind a question that has never been entirely settled. Was it a permanent structure that we glimpsed at the moment of its collapse? Was it always temporary, a chance configuration that could not persist? Or does it still exist somewhere, somehow, beyond our instrument's reach, waiting in the depths of Neptune's blue atmosphere? There remains a quiet humility in such uncertainty. We have sent one spacecraft to Neptune, captured one brief survey of its face, and in that single mission, discovered wonders and mysteries both. The great dark spot stands as a reminder that even our closest observations of the distant planets reveal to us only the thinnest surface of their true complexity. The storms of Neptune continue to swirl, visible and invisible, forming and dissolving in patterns we are only beginning to comprehend. And perhaps it is fitting that Neptune, the god of waters, should keep such secrets. Perhaps it is right that a planet wreathed in blue should maintain some final mystery, some reminder that vast distances still separate us from true understanding. The dark spot came and went like a dream half remembered upon waking, vivid in the moment of observation, troubling in its absence afterward, and forever leaving us with the gentle, insistent question of what more might be hidden in the deep blue winds of that distant world. And yet, if you were to float near Neptune right now, in the cold and lightless expanse beyond where the sun has nearly surrendered its warmth, you would notice something faint catching what little light remains, something almost apologetic in its presence. Neptune possesses rings. This fact alone might seem to contradict everything about the planet's serene countenance, for we tend to think of rings as the grand, bold statements of Saturn, those brilliant golden bands that announce themselves across the solar system. But Neptune's rings exist in whispers. They are partial, they are fragmented, they are, in the truest sense, delicate. The Nepturian rings were confirmed only in 1989, when Voyager 2 made its historic approach, though astronomers had suspected their existence decades before. What makes them so difficult to observe from such vast distances is their composition and structure, for unlike Saturn's rings, which are composed of countless particles of ice reflecting light with almost theatrical brightness, Neptune's rings are darker. They contain more dust, more meteoritic material ground down over eons of collision and decay, and they do not form complete circles around the planet. Instead, they exist as arcs, as incomplete bands, as segments that thicken and thin, like the phases of something organic undergoing slow transformation. Consider the elegance of this arrangement. Where do rings come from in the first place? This is a question that has occupied planetary scientists for generations, and the answer varies slightly depending on which ringed world you happen to be studying. For Saturn, the prevailing theory suggests that rings may be the remnants of a moon that wandered too close to the planet's gravity well and was torn apart by tidal forces. Or perhaps they are the pristine remains of material from the solar system's formation that never managed to coalesce into a moon at all. For Neptune, the situation appears somewhat different and altogether more transient in character. The theories that explain Neptune's rings tend to cluster around the concept of erosion and decay. You see, the rings we observe today are not permanent fixtures of the Neptunian system. They are, in a real sense, temporary. Everything in the cosmos persists within time, and time ultimately undoes all arrangements. Neptune's rings are gradually being depleted. Micrometeorites strike the ring particles constantly, knocking them away. The solar wind, that ceaseless stream of charged particles emanating from the sun, carries momentum that nudges smaller grains ever so slightly inward, toward the planet's vast atmosphere. Over timescales of millions of years, the rings are slowly disappearing, becoming fainter, thinner, less coherent. And yet simultaneously, new material is being added from other sources. The moons of Neptune play a crucial role in the architecture of these rings. Some of the rings are believed to be shepherd moons, a term that conveys the gentle image of a small body shepherding larger flocks, though in this case, the flock consists of icy particles and dust. These small moons orbit within and near the ring system, and their gravitational influence, subtle though it is across such enormous distances, helps to confine the ring particles to particular orbits. Without these shepherding moons, the rings would disperse more rapidly, spreading and diluting until they became imperceptible. The moons gather them, keep them together, maintain the delicate structure. It is a form of cosmic organization, a quiet collaboration between small bodies and vast systems. The names given to Neptune's rings carry a certain poetry. There is the Adam's ring, the Leverrier ring, the Gall ring, all named after astronomers and scientists whose work contributed to our understanding of this distant world. But there is also something called the Lassell ring, and arc systems with names like Courage and Liberté, borrowed from the historical language of human aspiration and virtue. These names map human meaning onto celestial architecture, reminding us that even at the very edges of our knowledge, we attempt to speak in our own language, to make sense of the incomprehensible by invoking concepts that move us. What remains striking about Neptune's rings, what invites a certain contemplative pause when considering them, is their impermanence framed against their vast age. The rings have existed for some considerable portion of Neptune's 4.5 billion-year history, and yet they will not exist forever. In 10 million years, perhaps sooner, the rings may be almost entirely gone, dissolved into Neptune's atmosphere, or scattered into space, or reassembled into entirely different configurations. The rings are not eternal monuments, but rather transient witnesses to the slow evolution of planetary systems. And this raises a gentle question that scientists still ponder. How do the arcs maintain their structure? How do segments of rings persist in incomplete form when gravity and physics would seemingly prefer symmetry and completion? The answer lies in resonances, in orbital mathematics that creates subtle wells of stability, where material can collect and persist. A moon, orbiting at precisely the right distance, will create, through its gravitational presence, a region where ring particles move more slowly relative to their surroundings, where they tend to cluster. This is stability emerging not from immobility, but from carefully balanced orbital dynamics, from invisible mathematical relationships made manifest in physical form. There is something profoundly reassuring in understanding this. The universe need not create perfect circles to create order. The rings of Neptune, fragmented and partial though they may be, represent an equally valid and perhaps more sophisticated form of organization, one that persists not through permanence, but through continuous adjustment, through the dance of gravity and momentum and time. They exist as arcs, because that is what the mathematics of orbital mechanics naturally produces under the specific conditions that prevail around Neptune. They are imperfect, yes, but they are also exactly as they should be, exactly as the laws of physics require them to be. There exists a moment in the archive of human space exploration that few pause to remember. August 25th, 1989, a Tuesday morning in the solar system's deep blue provinces. On that morning, a spacecraft called Voyager 2, a machine humanity had sent into the void 12 years earlier, drew closest to Neptune, passing through the system's ancient architecture of wind and ice and shadow. It was, and remains, the only human-built vessel ever to visit this distant world. Let that settle for a moment. Of all the billions of dollars spent reaching outward, of all the rockets and missions and grand ambitions, only one mission has ever gone so far, so deliberately, to witness Neptune up close. Voyager 2 was never primarily a Neptune mission. It had been born in the mid-1970s, conceived to visit Jupiter and Saturn, those magnificent giants that had captivated astronomers for centuries. But as the mission planners studied the trajectories, they realized something remarkable. If the spacecraft survived those encounters, if its instruments continued to function through the long, cold years of interplanetary travel, the mathematics of orbital mechanics offered a gateway. A rare planetary alignment occurred only once every 175 years, and Voyager 2, if it flew true, could thread that needle. It could visit both Uranus and Neptune in a single, unbroken journey. The engineers and scientists at NASA understood they were being given a cosmic gift, a window that would not open again in their lifetimes. By the time Voyager 2 reached Neptune, it had already traveled more than 4 billion miles. The spacecraft was a child of analog technology, carrying instruments that would seem quaintly primitive by the standards of today. Cameras with exposed film, radio transmitters broadcasting at a power no greater than a wristwatch, sending signals that took over 4 hours to reach Earth across the void. And yet, as the spacecraft descended into Neptune's realm, as it passed through the upper atmosphere and began its closest approach, those humble instruments began to see what no human eye had ever witnessed. They recorded images of a planet no longer theoretical, no longer a mathematical prediction or a name inscribed in astronomical tables. Neptune became real. It became visible. The cameras opened, and the golden photographs began their long radio journey home. What the images revealed was both familiar and astonishing. There were the clouds that scientists had predicted, methane-rich structures moving through that deep blue atmosphere, sculpted by the fastest winds in the solar system. The great dark spot emerged in the images, a storm system so vast that entire Earths could have been swallowed within it, and yet it appeared almost serene against Neptune's tranquil face. The photographs showed the planet's rings, delicate and incomplete, more suggested than present, like something observed through gauze. They showed the sheen and curvature of a world so distant that it had taken light itself 5 hours to escape its orbit and still be called near. And as each image was transmitted back to Earth at the speed of light, traveling at 186,000 miles per second, and still taking 4 hours, a room full of scientists watched a world materialize on their screens, a world most of them would never see with their own eyes, a world that might never be seen so closely again. What made Voyager 2's Neptune encounter particularly profound was precisely its solitude. This was not the beginning of exploration. It was not the opening of a frontier. It was a singular moment. After Voyager 2 departed Neptune's vicinity, no other spacecraft has followed. No orbiter has settled into Neptune's gravitational embrace. No lander has touched its surface. Though what would that surface even mean for a gas giant? A world with no solid ground, only an infinitude of pressure and cold descending toward an imagined interior. The Neptune system had been visited once, and then, in the mathematics of spaceflight, it had been left behind, sealed away again in distance and indifference. The photographs that Voyager 2 sent home during those hours of closest approach were not ordinary scientific images. They were, in some profound sense, the last we may ever see of Neptune rendered in such detail, the last intimate portrait humanity may record of that distant world. The spacecraft carried something else too, a golden record, a message from Earth encoded in grooves and electromagnetic impulses, a declaration of human presence addressed to whatever might listen in the cosmos. After Neptune, Voyager 2 continued outward, still transmitting, still alive, moving deeper into the Kuiper belt and toward interstellar space, its instruments failing slowly one by one, its signal growing fainter with each passing year. There is something that settles the mind about this solitary visitation, this single encounter with a world so far away, so difficult to reach, that one mission's data might represent humanity's primary window into that region of space for generations to come. The finality of it carries a strange comfort. We sent Voyager 2 as an emissary, and it delivered its message, and then it moved onward into the dark. The photographs remain, suspended in archives, waiting to be examined and re-examined, each viewing revealing details that time and technology make newly visible. Neptune receded again into distance, becoming once more a point of blue light in telescopes, its mysteries preserved in the data streams and image files of a spacecraft that, even now, continues its voyage deeper still into the vast and patient silence. And yet Neptune, for all its solitary grandeur at the edge of the solar system, is not alone. It holds within its gravitational embrace a moon unlike any other in our corner of the cosmos, a world so strange and beautiful that its very existence poses one of astronomy's most patient mysteries. This is Triton, a sphere of ice and cold fire that orbits its parent planet in a direction that defies expectation, moving backward through the Neptunian sky, retrograde, as though it had been caught mid-flight and forced into an eternal reversal of direction. Triton is massive in its own way, larger than our own moon, substantial enough that it shapes the very space around Neptune with its presence. And yet, what makes Triton truly extraordinary is not merely its size, but the landscape that covers its frozen surface, a realm of ice that is anything but dead. Here, beneath a thin atmosphere of nitrogen, the surface tells a story of geological activity that seems almost impossible in such a cold and distant place. Across Triton's icy crust, there are volcanoes, not the molten, fire-breathing mountains we know on Earth, but cryovolcanoes, geysers that erupt not with lava, but with nitrogen ice and methane, plumes that rise from the interior and spray outward into the frozen vacuum, then fall back down like reversed snow, coating the landscape in layers of exotic frost. These eruptions, gentle in appearance yet violent in their release, suggest that beneath Triton's icy shell there lies a source of internal heat. How such heat persists in a body so far from the sun, so far from the primary sources of thermal energy we might expect, remains a question that astronomy continues to ponder. Perhaps it is tidal heating, the constant flexing and squeezing of Triton's interior as it orbits Neptune, friction generated by its close relationship with the planet creating warmth in the depths. Or perhaps there are radioactive elements within its core, decaying slowly through billions of years, releasing energy in amounts just sufficient to power these nitrogen geysers, these gentle explosions of ice. What truly captivates those who study Triton, however, is the question of its origin. For Triton's retrograde orbit, the fact that it moves backward relative to Neptune's other moons, traveling in the opposite direction from the planet's spin, tells a story of capture rather than formation. This moon did not coalesce from the primordial dust cloud that gave birth to Neptune's system. Instead, Triton was born elsewhere, somewhere in the vast and distant Kuiper Belt, that realm of icy bodies that orbits at the edge of our solar system, beyond even Neptune's current orbit. And then, at some point in the distant past, perhaps billions of years ago, Triton wandered too close. Neptune's gravity caught it, pulled it inward, and the moon that had been a free wanderer of the outer solar system became a captive, bound forever to orbit the great blue planet. This capture must have been a cataclysmic event, one of those rare cosmic collisions that reshape worlds. When Triton was drawn into Neptune's orbit, the gravitational forces at work would have been immense, far beyond anything the young moon had ever experienced. Its trajectory would have been elliptical at first, highly eccentric, oscillating in a wild dance with its captor. Over millions of years, through a process called tidal circularization, Triton's orbit gradually became more regular, more stable, the wild swinging eventually dampening into something resembling equilibrium. Yet even in that capture, there would have been heat, tremendous heat generated by the tidal flexing, by the deformation of Triton's interior as it was wrenched into a new orbit. This heat, this internal warming from the trauma of capture, may have been sufficient to power the internal activity that persists even now, billions of years later, in the form of those cryovolcanoes and nitrogen geysers. The evidence for this capture lies not only in Triton's retrograde orbit, but in its composition as well. Triton is made of ices, frozen water, methane, nitrogen, the substances that populate the Kuiper Belt far more commonly than they occur in Neptune's inner system. Its density, its surface features, its geological character all point unmistakably toward an origin among the icy wanderers of the outer solar system. Triton, in essence, is a Kuiper Belt object that wandered too close to Neptune and was held fast, transformed from a solitary traveler into a moon, from independence into captivity. And as Triton orbits in its retrograde direction, completing one circuit around Neptune every 5.5 days, it gradually spirals inward. The same tidal forces that once trapped it are now slowly drawing it closer. Sometime in the distant future, perhaps 1 billion years hence, perhaps longer, Triton will venture too close. It will cross what astronomers call the Roche limit, the boundary beyond which a body cannot withstand the tidal forces exerted by its host. At that point, Triton will be torn apart, its ices and rocks scattered, perhaps becoming a ring system that will briefly encircle Neptune before gradually falling into the atmosphere. The moon that was once a wanderer of the Kuiper Belt will be unmade by the very forces that captured it. But that is a fate that lies inconceivably far in the future. For now, Triton remains, a paradoxical world, frozen yet active, distant yet intimately bound to Neptune, a living reminder that even at the edge of the solar system, in the cold and darkness, worlds still tell their stories, still bear the marks of their distant past, still whisper secrets to those patient enough to listen. Beyond Triton's icy, cratered face, there circles a collection of smaller moons whose names read like whispers in a language most of us have never learned. Proteus is the largest of these distant companions, a world so far removed from the sun that it exists in perpetual twilight, shaped like a vast, irregular potato tumbling through the void. When Voyager 2 caught sight of it in those final moments of its Neptune encounter, scientists were struck by how battered this moon appeared, its surface cratered and scarred, as though it had weathered an eternity of cosmic collisions. Yet there is something almost peaceful about Proteus, something calming in the thought of a world so ancient, so weathered, yet still faithfully orbiting in the dark. Nestorum and Thalassa drift along in their own peculiar paths, small enough that you might hold them in your imagination, the way a child cradles a smooth stone. Thalassa especially seems almost fragile, barely 300 kilometers across, yet it has maintained its orbit for billions of years, a testament to the enduring stability of Neptune's gravitational embrace. And then there is Despina, whose name carries a melancholy beauty, circling closer to the planet than many of the others, moving through the darkness with a quiet inevitability. These moons are not the dramatic centers of astronomical attention the way Triton is. They do not boast of ice volcanoes or impossible retrograde paths. Instead, they represent something gentler, something more meditative in the cosmic order. Each one, no matter how small or overlooked, maintains a rhythmic path through the void. Each one, a small anchor of gravity and substance in the overwhelming emptiness that surrounds Neptune's domain. Have you ever considered what it means for something so distant, so seemingly insignificant, to remain constant in its orbit? There is a kind of reassurance in that constancy, a reminder that even in the remotest corners of our solar system, the laws of physics hold true, binding these small worlds to their immense parent planet with invisible threads of attraction. What draws astronomers to study these lesser moons is partly curiosity, partly the scientific instinct to understand every piece of a puzzle. But there is also something profoundly human in it, a desire to give names to even the smallest objects in the darkness, to say, yes, you exist, you matter, you are part of the tapestry. Nereid floats among them as well, following a decidedly unusual orbit that remains one of astronomy's lingering mysteries, an ellipse so eccentric that it suggests a violent past, perhaps a close encounter that sent this moon careening into its current path long ago. The smaller moons of Neptune exist in a condition of profound isolation that is perhaps difficult to fully comprehend from Earth. They are not visited by spacecraft. They are not photographed in detail. Most of what we know of them comes from that single brief encounter with Voyager 2, supplemented by observations from Earth-based and orbital telescopes that gather only the faintest light reflected from their distant surfaces. Yet knowing this does not diminish them. If anything, it deepens the sense of wonder. These worlds continue their silent, patient journeys around Neptune, regardless of whether any conscious being observes them or not. They simply are, following the mathematics of gravity, with an indifference to whether they are known or unknown. Think of them as the quiet members of Neptune's retinue, the lesser courtiers who attend the grand giant without demanding attention. Larissa, Galatea, Halimede, each name carries a story, each assigned by those who studied the heavens and drew upon the mythology of the sea, as if the ocean gods and nymphs had themselves migrated across the vast gulf of space to attend their distant watery world. There is a poetry in that, a recognition that even in the farthest reaches of our solar system, the human impulse toward naming, toward creating narrative and connection, still reaches outward. And in the slow, darkened quiet of contemplating these small moons, there exists a particular kind of meditation. They ask nothing of us. They simply exist in their orbits, circling a giant planet that itself circles an ordinary star, all of it unfolding on a timescale so vast that a human lifetime is merely a blink. Yet within that blink, we have discovered them, named them, and come to know something of their nature. There is a quiet satisfaction in that knowledge, a gentle reassurance that even the smallest objects in the darkness are not truly unknown, not truly unreachable to human understanding, no matter how distant they may be. They remain there still, in the cold and the dark, faithful to their paths, asking nothing but to continue their slow, eternal journeys through the void. And yet, beneath that serene blue surface, invisible to any telescope or camera, there exists a force of tremendous power, a magnetic field that extends far beyond Neptune itself, shaping the dance of particles and light in the darkness around it. This field, invisible as it is, forms one of the planet's most enigmatic features, a realm of physics that operates in silence, pulling and curving and ordering the chaos of space in ways we are still learning to understand. Neptune's magnetic field is peculiar in its architecture. Unlike Earth's field, which aligns reasonably close to the planet's axis of rotation, Neptune's magnetic field is tilted at an angle of roughly 47 degrees, nearly perpendicular, in a sense, to the way the planet spins. Imagine a great invisible force, radiating not from Neptune's poles, but from points far to the side, a tilted dipole sweeping through space as the planet turns. This unusual orientation means that the magnetic poles and the rotational poles of Neptune are worlds apart, a cosmic misalignment that scientists still contemplate with quiet fascination. The source of this field lies buried somewhere within Neptune's interior, in those layers of ice and pressure we discussed earlier, or perhaps in the churning of electrically conductive fluids deeper still. The precise mechanism by which Neptune generates its magnetic field remains something of a mystery. For how exactly does a world composed so largely of ice and gas produce such a powerful magnetic presence? Some suggest that conducting layers of water and ammonia, perhaps mixed with silicates, move through the planet's interior in convective currents, creating electrical currents that birth the magnetic field much as they do within Earth. Others propose mechanisms we have yet to fully map or test. The truth is that we observe the field's effects, we measure its strength and tilt, but the engine that drives it continues to elude complete understanding, a gentle reminder that even in our age of spacecraft and simulation, the planets hold secrets still. This tilted field has profound consequences for Neptune's interaction with the solar wind, that constant stream of charged particles flowing outward from the Sun. Around most planets, the solar wind compresses the magnetic field on the side facing the Sun and stretches it into a long tail on the night side, creating a comet-shaped magnetosphere. Neptune's magnetosphere is similarly shaped, but its tilt means that as the planet rotates, its magnetic field sweeps around like a great lighthouse beam made of invisible force. The geometry is complex, asymmetrical, creating regions of compression and expansion that shift and pulse over the course of a Neptunian day. And remember, Neptune rotates once roughly every 16 hours, so these magnetic storms and stirrings occur in a rhythm utterly alien to human experience. This sweeping, tilted field also captures and contains charged particles, trapping them in radiation belts that circle the planet. These particles dance along invisible magnetic field lines, spiraling around them, trapped in a ballet choreographed by forces that have existed since Neptune's birth. In some ways, these radiation belts are Neptune's invisible crown, a halo of energized matter that surrounds it constantly, touching nothing, seen by no eye, felt by nothing but the planet's own invisible grasp. The tilt of Neptune's magnetic field relative to its rotation creates another phenomenon of subtle beauty. The magnetic axis precesses, or wobbles, slowly over time. This is not something we have observed directly. Neptune has been visited by only one spacecraft after all, and our observations from afar cannot yet reveal such gradual shifts. Yet the physics predicts it, the mathematics whispers of it, and we accept it as likely true. Somewhere in the darkness beyond Triton's icy embrace, Neptune's magnetosphere rocks back and forth in patterns we can only imagine, invisible forces choreographing a dance that will continue for billions of years more. What does this magnetism mean for Neptune itself? In a practical sense, it influences the structure of the upper atmosphere. It shapes how solar wind particles interact with the planet's gases. It creates regions of electrical activity and energy discharge that we may one day study in greater detail. But on a deeper level, the magnetic field is a signature of Neptune's internal activity, evidence that despite the planet's serene blue face, despite the meditative calm of those deep blue cloud formations, There is motion and heat and transformation happening within. The field is a statement of internal complexity, of processes ongoing in the darkness, of a world that is far more dynamic than its gentle appearance would suggest. The tilt itself raises gentle questions that scientists continue to explore. Why is Neptune's magnetic field tilted so dramatically when most planetary magnetic fields align more closely with their rotation? Is it a remnant of ancient collisions or gravitational interactions? Is it the result of the planet's deep interior structure, perhaps an asymmetry in the distribution of materials within that high-pressure mantle? Or might it be something else entirely, some consequence of Neptune's formation in the chaos of the early solar system that we have yet to reconstruct fully? These questions remain open, patient, waiting for future exploration and measurement to illuminate them. And as Neptune turns, silently, endlessly, in the cold distance from the sun, that great tilted field turns with it, sweeping around the planet in patient circles, an invisible power that binds particles to the void, that shapes the space around Neptune into regions of order and containment. For 16 hours and 7 minutes the field rotates, and then it begins again, millions of times over, millions of years, a rhythm so patient and so vast that it becomes less a motion and more a property of existence itself, the magnetic nature of Neptune, as eternal and as distant as the stars it circles beneath. And so we arrive at Neptune, that distant sentinel standing watch at the edge of our solar system, a guardian of time and silence so profound that it reminds us, in the gentlest possible way, of our own smallness and fragility beneath the infinite dark. Neptune does not rush. Neptune does not demand our attention with bright light or dramatic gestures. It simply endures, turning slowly through the centuries, patient in ways that human minds can barely comprehend. When you consider that Neptune has completed only one full orbit around the Sun since it was discovered by human calculation and observation, you begin to grasp something essential about scale. The astronomers of 1846, who first witnessed this pale blue world through their telescopes, have long since turned to dust and memory, yet Neptune continues its ancient, unhurried journey. In the time it took for that one orbit to complete, human civilization has transformed from gas lamps to electric light, from horse-drawn carriages to machines that circle the Earth in 90 minutes. Empires have risen and fallen. Generations have lived their entire lives, loved and struggled and rested, all within the space of a single Neptunian year. What does that mean for our sense of urgency, our constant feeling that time is slipping away? Perhaps Neptune teaches us something about patience, about the value of slow, steady persistence through an incomprehensibly vast canvas of space and time. The planet does not race through the heavens. It does not compete for our notice. It turns in the cold and dark, surrounded by its delicate rings and its strange moons. Triton with its backward dance and its icy geysers, the smaller companions spinning in their quiet orbits, and it simply continues. There is no anxiety in that continuation. There is no hurry. Consider, too, the invisible forces that we have explored together in these hours, the magnetic field that tilts and swirls, the crushing pressures that may well transform carbon into diamonds in the depths of that slushy, hidden mantle. Neptune holds its secrets close. We know so little about what truly dwells in its interior, what exotic states of matter might exist under conditions we can barely simulate in our laboratories. And there is something deeply peaceful about the mystery of it. Not everything needs to be solved. Not everything needs to be exposed to light and analysis. Some mysteries can simply remain, deep and beautiful and ultimately unknowable, reminding us that the universe holds wonders beyond our grasp. The winds of Neptune, those ferocious jets of gas that scream across the planet's face at speeds that would obliterate anything we might try to send into them, those too are part of the paradox. Beneath that serene, tranquil blue exterior, that gentle blue that comes from methane molecules absorbing the red light of the distant sun and reflecting back only the cool colors of water and sky. Beneath all that calm lies turbulence and violence and energy that we are only beginning to understand. And yet from our vantage point here, knowing all of this, looking back at that pale blue dot in the darkness, we perceive it as peace itself. Perhaps that is the true nature of Neptune. Perhaps from the distance of billions of miles, all the storm and fury becomes a kind of stillness. When Voyager 2 made its brief encounter with Neptune in 1989, racing past at tremendous speed, it sent back images and data that stunned the scientists waiting to receive them. For those few hours of closest approach, humanity's mechanical emissary reached out and touched the face of this distant world, and then it drifted on, away into the interstellar medium, carrying with it a golden record inscribed with the sounds and images of Earth. And Neptune continued on its way, untouched, unaltered, indifferent to the moment of contact. The spacecraft traveled for more than 13 years just to reach that planet. 13 years of voyaging through the vast emptiness of space, and when at last it arrived, the encounter lasted only hours before separation was permanent and eternal. That image, a tiny machine traveling through decades of darkness to obtain mere hours of contact with a world it could never truly know or touch or understand, that image contains within it something beautiful and terrible and humbling. It speaks to the limits of our reach, the vast distances that separate worlds, the way in which the universe is fundamentally a place of separation and distance and loneliness, interrupted only by the brief moments when minds reach out across the dark and touch something beautiful. Neptune, that slow-turning sentinel, has been keeping its vigil for billions of years. Long before humans existed, long before life emerged on Earth, Neptune was there, turning through the cold and void. Long after we are gone, it will continue turning, patient and inexorable and eternal. The planet asks nothing of us. It makes no demands. It simply exists in its distant orbit, a reminder that time is longer than our lives, that space is vaster than our travels, and that there is a kind of peace in accepting our place within something so much larger than ourselves. Think of Neptune when you feel rushed or anxious or overwhelmed by the demands of a single day, a single moment, a single breath. Think of how that world has spent 165 years completing one slow orbit, how it turns with the patience of centuries, how it endures in the dark with neither complaint nor urgency. Neptune is still there, waiting in the infinite night, holding its slow, ancient watch over the rim of our solar system. And in some small way, by simply knowing it is there, by feeling the gentle pull of that knowledge, we are less alone in the darkness. The universe is vast and cold and ultimately indifferent to our existence, and somehow, in that cold indifference, there is a strange and quiet comfort.